Very good evening. So today we are going to discuss the chapter of mechanical properties of solids. Okay, so here in today's class we are going to discuss interatomic and intermolecular forces. Second one, stress and its types. Third one, strain and its types. So these are the three topics we are going to discuss in today's class. So from the chapter of mechanical properties of solids, in the NEET examination continuously they have been giving one question from this chapter. So very a small chapter when you are comparing with other chapters, and also very important one because you can able to solve the numerical related to this chapter. So here the most important concept of the chapter is Young's modulus. There we have different cases and all. We can practice more. We need to practice more number of numericals on Young's modulus. Many times they ask for a question from this, the concept of Young's modulus. So along with Young's modulus, other topics are also important. We need to discuss all the topics related to this chapter. Okay, right. Now we will discuss interatomic and intermolecular distance. So interatomic and intermolecular forces. Interatomic and intermolecular forces. So here based on this interatomic and intermolecular forces, we can able to understand how the solids are forming the situation. For example, if you are taking a solid, this is first topic of the chapter. In the case of solids, so solid is nothing but collection of atoms with very closed, those atoms are very closely packed together. That is known as solid. Now for example, you have taken individual atoms like that. So these are individual atoms. Now by bringing all these atoms together with closely packed with each other, then we can able to form a solid state material. Now solid or liquid or gases are nothing but collection of atoms. In the case of solids, atoms are closely bound together. Now like that we will take two atoms. Atom is nothing but a positive nucleus surrounded by negative electron. So electrons are revolving in their particular orbits, and at the center, the nucleus, inside the nucleus there is protons. So nucleus having positive charge and electron is revolving in their particular respective orbits. This is one atom. Now we can take another atom. This is another atom which is also having positive nucleus, and electron is revolving in their outermost orbit. Now the distance between these two is greater than 10 to the power of minus 10 centimeter. This is called atomic size. If distance between them is greater than 10 to the power of minus 10 centimeter, there is no interaction between these two atoms. But when the distance between these two atoms became in the order of 10 to the power minus 10 centimeter or less than this one, then there is attractive and repulsive forces are acting between these two atoms. So what is the reason for those attractive and repulsive forces? So here the possibilities are, this is electron and this is electron. So these two are electrons belongs to neighboring atoms. Now there is a repulsive force between these two electrons, these two electrons, and there is a repulsive force between these two positive nucleus because like charges will repel with each other, and there is attractive force between this positive nucleus and this electron, and there is an attractive force between this negative electron and this positive nucleus. Like that, when these two atoms are bringing together, when the separation between them is in the order of 10 power minus 10 centimeter, what happened? So there are forces between these two atoms. What type of forces are? They are electrostatic forces between electron and electron, proton, that means we can take it as nucleus and nucleus, or electron of one atom to the positive nucleus of that. So these are all the forces we can call as intraatomic forces. Now what are these intraatomic forces? Are electric forces. So now we can say interatomic and intermolecular forces. Intraatomic and intermolecular forces are electric in nature. So intraatomic and intermolecular forces are electric in nature. So this is the point we need to understand from this explanation. So for objective examination. Okay. So intraatomic and intermolecular forces are electric in nature. You know, electrostatic forces or electric forces are conservative forces. So we can say interatomic and intermolecular forces. Interatomic and intermolecular forces are conservative forces. You know, work done by the force does not depend on path followed by the body. It depends only on initial and final positions. Then the force is known as conservative force. So intraatomic and intermolecular forces. So electrostatic forces, gravitational force, electrostatic force, elastic force, or spring force. So these are all conservative forces. So frictional force, viscous force, these are called non-conservative forces. So as intraatomic and intermolecular forces are electric forces, as electric forces are conservative forces, we can say intraatomic and intermolecular forces are conservative in nature. So about this conservative forces we already discussed in the chapter of work energy power. So here conservative force we can define as negative of potential energy gradient. So this is very important expression. So based on this expression they asked the question in the previous NEET examination and also in JEE mains examination. So interatomic force can be interatomic force and intermolecular forces are conservative forces. Conservative force may be defined as negative of potential energy gradient. So now interatomic and intermolecular forces are electric forces. They are nothing but attractive and repulsive forces. So when there is a possibility of attractive force and repulsive forces, when the separation between them is in the order of 10 power minus 10 centimeter, then there is an attractive and repulsive forces. So when this distance is more, attractive forces will dominate. When these two distances very closer together, that means distance is decreasing, then automatically because of like charges, there is repulsive force is also dominating these attractive forces. So at a particular separation, these attractive and repulsive forces are balancing with each other. That is called equilibrium separation. So with the distance, that means with separation between these two atoms, how these intraatomic and intermolecular forces are changes we can express in terms of graphical representation. So this graphical representation they may ask in the examination. Okay, right. Now we can take a single graph which is useful to represent both the force and potential energy. Now we can take graph is looking like this. This is intraatomic force F on y-axis. Separation between the two atoms is R. Now if the separation between the two atoms became in the order of 10 power minus 10 meter, interatomic forces will act. If order is 10 power minus 9 meter, then its order will becomes 10 power minus 10 meter, not centimeter, 10 power minus 10 meter. Okay, right. Now, so there is attractive force acting between these two. Now, minimum attractive force will act. As separation is decreasing, then attractive force will increases, and it will becomes a maximum at a particular separation, and then attractive force will decreases, and then become zero. Now, repulsive force will dominates. Okay. Now, this from this graph we can understand. So this is attractive force is minimum. As we are decreasing the separation between the two atoms, attractive force is increasing and will become so maximum. So here this is the point where attractive force is maximum. We know attractive force is negative, whereas repulsive force is positive. So that is the reason. So attractive force is in negative coordinate. So here the attractive force is maximum. The corresponding distance where the attractive force is maximum is known as, which is represented by X. This is called critical distance. So critical distance is the separation between the two atoms where the attractive force will becomes maximum. Now this is attractive force. Now when at this point attractive force is balancing the repulsive force. Now in this case, in positive coordinates, as repulsive force is positive, this is repulsive force. So in positive coordinate repulsive force, in negative coordinate attractive force will becomes maximum at a particular point. The separation between the two atoms where an attractive force is maximum is called critical distance. This is how the force is changes with respect to separation between the two atoms. Okay. Now the same we will represent with potential energy. Now we can take this is U, potential energy, and this is the graph. Okay, right. Now we can extend this point like this to understand the similarity between the two. This point is like this. So what is potential energy? Potential energy is U is equal to A by R to the power of N minus B by R to the power of M. This is the general form of the potential energy. So in general, for most of the solids, so potential energy we may define as U is equal to A by R to the power of 12 minus B by R to the power of 6. So here this A by R to the power of 12 is belongs to positive. This is nothing but component of repulsive force. So this term is representing attractive force. So this negative is attractive, positive is repulsive. Okay. Now this is the point where attractive and repulsive forces are balancing with each other. So at this point, what is the net force? Net force will be equal to 0. So net force will be equal to 0. That means du by dr is equal to 0. That means u is remains constant. U is remains constant. So there, where the potential energy, now the potential energy graph we can expect like this. This is the potential energy graph. Okay, this is a separation between the two atoms. Now here you see, this is the point where potential energy is becoming maximum. Now this is the point corresponding to what? That is the point corresponding to attractive force is maximum. So this is the point related to attractive force or maximum attractive force. Maximum attractive force. You see here, this is related to maximum attractive force. So in general, so what is the question they asked in the previous examination is, they given potential energy separation between the two atoms graph, but they will ask the point related to force. As when we are comparing these two graphs, so this is the point where attractive and repulsive forces are balancing. So where the potential energy value will becomes minimum. Now the separation between these two, now this separation is called R naught. R naught is called equilibrium separation. So the separation between the two atoms at which both attractive and repulsive forces are balancing is known as equilibrium separation. So at equilibrium separation, what happens? At R is equal to R naught, net force will be equal to 0. That means du by dr is equal to 0. Du by dr is equal to, so based on this we will ask the numerical. So from this graph, what you need to understand, we need to identify is, what is the point? They will give some points on this graph. This is point, this 3 point. This is A, this is B, and this is C. So at which of the following points attractive force is maximum? So they won't mention this force separation graph. They mention only potential energy separation graph. So from this potential energy separation graph, so this is the point corresponding to maximum attractive force. So at point B, attractive force is maximum. Okay. So like this, we need to identify the graph. Okay. So here, what are the key points for the objective examination is, I will say. So first point, what is the point we need to observe is, intraatomic and intermolecular forces are electric forces. So these electric forces are conservative forces. Then intraatomic and intermolecular forces are conservative forces. Next, second one is, for a conservative force we can define F is equal to minus du by dr. This is the other point we need to get. And then at R is equal to R naught. At R is equal to R naught, what happens? Net force will become 0. That is du by dr is equal to 0. So based on this, they will ask mathematical, numerical. Okay, right. And then graph question, graphical representation question. They will ask on this model of the graph. Okay. So these are the important key points from the topic of intraatomic and intermolecular distances. Okay. So R naught is called equilibrium separation at which both attractive and repulsive forces are balancing with each other. So that is called equilibrium separation. So net force will be equal to 0. Okay. So based on this, what are the questions they may ask? Model of questions they will ask from the topic of intraatomic and intermolecular forces. We will see now. we'll see the question based on this. Okay, now say this question. The point of maximum and minimum attraction in the curve between potential energy and distance r of diatomic molecules. So position given. Now we have a diagram for force and separation. Now above this we can expect the force diagram. So force diagram. So this is the point related to maximum. So force diagram will like this. So this is the point corresponding to critical distance x, critical distance. So the point attractive force, this is a force separation graph, force separation graph. So this is the point corresponding this maximum attractive force, point is corresponding to s. At this point minimum, at this point minimum. So this is maximum attractive force. So this is the point corresponding to R0. What is R0? R0 is the separation between the two where attractive and repulsive forces are balancing with each other. So what are the points they are asking? Maximum and minimum attraction. So maximum attraction at the point S, minimum attraction at point T. Okay, so S and T. So like this they will ask the question from the graphical representation. Okay, that is the first one question. And okay, see this point, potential energy U between two molecules is a function of distance x between them has been shown in the figure that the two molecules are. You see now here what is this point? So this is the point where attractive and repulsive forces are balancing with each other. That is called equilibrium separation R0. Net force will be equal to 0. Now before this, at this point what happened? Attractive force is maximum. So below this repulsive force is maximum. That means always attractive and repulsive forces are present, but based on the separation between the two atoms, attractive force may dominate at some places, repulsive force may dominate at some places. That is based on the separation between the two atoms. So between B and C, what type of force will exist? Attractive force. So at point B, attractive force and repulsive forces are balancing. That means in the region of B to C, attractive force is dominating. So both the forces are present at all the times. But in this case, B to C, attractive force will dominate. At point B, attractive force is equal to repulsive force. So below this point, so that means A to B, what happened? Repulsive force will exist. So this is repulsive force, forces are balancing, and this is attractive force. So these molecules attracted when X lies between B and C. So attraction B and C, and repelled when X lies between A and B. So this is repulsive and this is attractive force. Then we can go with option 2. Attracted when X lies between B and C, and repelled when X lies between A and B. So these are the two model of graphical questions they may ask from this force and separation or potential energy separation graphs. Okay. Next, mathematical question, how they will ask on this concept of intraatomic and intermolecular distance. The potential energy function for one force, for the force between two atoms in a diatomic molecule is approximately given by this one. This is potential energy where A and B are constant and R is the distance between the atoms. If the dissociation energy of the molecule is, so dissociation energy, what they are giving, potential energy at R is equal to infinity. So potential energy will exist, interaction, potential energy is nothing but interaction. So interaction will exist only when the two atoms are in the order of 10 power minus 10 meter. This is called atomic size. Atomic size. So when the two atoms in the range of atomic size, then only there will be an interaction between the two atoms. So when this R is equal to infinity, that means greater than this 10 power minus 10 meter, there is no interaction. That means potential energy at R is equal to infinity will be equal to 0. So what is the dissociation energy is already given as like this. There is the difference in potential energy between R is equal to infinity to at equilibrium. So what is equilibrium means? Equilibrium means R is equal to R naught. R is equal to R naught. So at R is equal to R naught, what when attractive force is equal to repulsive force, that means net force will become 0. Net force will become 0. Now as this is 0, so this U of R is equal to infinity is equal to 0 minus, so potential energy. So now we need to find dissociation energy is equal to minus U at R is equal to R naught. R is equal to R naught. Now, so how can you find this the value of U? Value of U at R is equal to R naught. So at R is equal to R naught, what happens? Net force will become 0. Net force will become 0. Now we need to take F U is equal to as given as R by 12 minus B by 6. Now from this conservative force definition, we can go with F is equal to minus du by dr. So by differentiating at equilibrium, so at R is equal to R naught, they are saying force is equal to 0. Then we can calculate the differentiation we need to do, and by substituting the value of F is equal to 0 here, we will get dissociation energy will be equal to B square by 4. B square by. So this is how they will ask the questions based on this one. So this is AIEEE 2010 question. Thus now it is we can call it as JEE main examination. Okay. So these are the three different types of questions they may ask from the concept of interatomic and intermolecular. Forces. Okay. Right. That is the first concept. Next, second one, stress. So when I take in one body, this is nothing but a material. So the solid state material is nothing but collection of atoms. Like this, atoms are collected and it forms a material. This is material. Now these two atoms are placed at the separation. At the separation, attractive and repulsive forces are balanced. This is called equilibrium separation. So these all atoms are at equilibrium separation. That means net force will be equal to 0. So these attractive and repulsive forces are balancing. The net force will be equal to 0. The separation between them is R naught. So this is the state of stable state of all the atoms or molecules of the substance. By now we are applying some force on this material to change its structure or to deform its structure. That force what we are applying on this solid state material is known as deforming force. Deforming force. So because of this deforming force, what happened? The structure of this solid is changing. According to Newton's first law of motion, according to law of inertia, every body try to exist in its own state or rest position, or that we can by the symmetry we can understand what is the original state of the body. In that state the body will always try to keep in that, maintain that state. But by the application of this deforming force we are going to change the structure of this body. So now because of that inertia and symmetry of the nature, so this is solid state material will try to restore its original size and shape. That property of the material is known as elasticity. So because of the property of this elasticity, this body will exert a restoring force. So what is restoring force? Deforming force is trying to destroy its structure of the material. Now because of the elasticity nature of this material, by the symmetry of the nature, so it is applying an restoring force. With this restoring force, based on the property of the material, it is always trying to balance this deforming force to maintain its original structure, size and shape. Now the restoring force acting per unit area of cross section of the material is known as stress. So stress we can define as stress is equal to restoring force by area of cross section, so which is equal to, so restoring force is trying to balancing this deforming force. We can say in magnitude, which is equal to deforming force by area of cross section. So stress is equal to restoring force by area of cross section, or deforming force by area of cross section. Now we can write stress is equal to F by A. Here A is nothing but area of cross section. Now if material is in the form of wire, so wire having circular area of cross section, so the circular area of cross section having radius R. Now we can write stress is equal to force by area, which is equal to force F by pi R square. So if the body is having circular cross section. Now SI unit for force Newton by meter square. CGS unit dyne per centimeter square, and dimensional formula ml t power minus 2 by area of cross section is L square. Now square L cancel, this is m L inverse t power minus 2. So the internal restoring force acting per unit area of cross section is known as stress, which is equal to deforming force. Restoring force is equal to deforming force, then deforming force by area of cross section. Now stress is equal to force by area, or F by, if it is having circular cross section, we can take that area as pi R square. Then SI unit is Newton per meter square, and CGS unit is dyne per centimeter square. Dimension formula m L inverse t power minus 2. Next, types of stress. So there are two types of stress. First one, normal stress. So normal stress means which is acting normal to the surface. So this normal stress will cause for the change in length of a body. This is called longitudinal stress. Again, this normal stress is caused for the change in volume. This is called volume stress or bulk stress. So there are two types of stress. First one is normal stress. This normal stress is nothing but a stress which is applied normal to the surface or normal to the area of cross section is known as normal stress. So this normal stress causes for the change in length of a body. That stress is called longitudinal stress. The same normal stress is cause for the change in volume of the body. Then that stress is called volume stress or bulk stress. Right. And second one is shear stress or tangential stress. So which is acting tangential to the surface. So normal stress is nothing but acting normal to the surface or perpendicular to the surface. Shear stress or tangential stress is stress which is acting tangential to the surface is known as shear stress. So this will cause for the change in shape of a body. So these are the two types of stress. So otherwise we may take it as three types, like that when you take it means longitudinal stress, volume stress and shear stress. But actually these two belongs to same category, that is normal stress. So normal stress and shear stress. Normal stress will change length of a body or volume of the body. So length changes means longitudinal, volume changes means volume stress or bulk stress. Shear stress is change in shape of a body. Next. For an isotropic solid, which means properties of the material or isotropic solid, properties of the material is same in all the directions, that is called isotropic solid. So for an isotropic solid, longitudinal stress is to shear stress is to bulk stress or volume stress is equal to 1:2:3. This is for an isotropic solid. So for an isotropic solid, longitudinal stress, shear stress and volume stress or bulk stress ratio will be 1:2:3. 1:2:3. Now here, so how we are applying normal stress? For example, we are taking to understand this normal and shear stress. If we are taking, this is a wire is having a circular cross section. Now normal stress, that means this is called area of cross section. This is called area of cross section, that we can take it as this is area of cross section. Now normal stress is acting like this. So this is how the normal stress is acting. So because of this normal stress, if length of a body is changes, means we can call that as longitudinal stress. If normal stress is acting in all the directions, then volume of the body will changes. Then that is called volume stress. Now if a body is or if a wire is like this, so in general this shear stress we can understand with the help of strain case we can easily apply. Now by fixing lower end of the wire, so we need to apply stress tangential to the surface. So this is called shear stress or tangential stress. So parallel to the surface or tangential to the surface, that is called shear stress. So shear stress is cause for the change in shape of the body. Okay, right. So here the situation is, in this case, this is area of cross section. So in general, this area of cross section is flattened surface. Now this is the normal. So along this normal, if you are applying stress, that is called normal stress. If the material is not having this cross section, that means in general cross section is like this, flat cross section of the material. But this material having a cross section, inclined cross section, that means the material cross section is looking like this. This is the shape of the material. Not having flat cross section, it has inclined cross section. So in this case, how we can find this shear stress and tangential stress? Now we can take, this is an angle theta which is making with original cross section. Now we need to apply force like this. This is the force. Now this can result into components. Now I will draw the diagram in the side. I will draw the diagram. Now we can take like this. This is the area of cross section. This is theta. Now we are applying force like this. Okay, right. Now we need to take component of these two forces which are acting like this. That means component of force which is acting in this way and in this way. Okay, now so this point we are discussing here. Now this is theta, this is 90, this will be 90 minus theta. Now opposite angle 90 minus theta, so this is theta. Now this is force F. As this is theta, we can take this as F cos theta and this is F sin theta. So F cos theta is the component of the force which is acting perpendicular to the cross section. So this is the component of the force. This here we need to take as this is theta. Now this is F cos theta and this will be F sin theta. Now this is tangential component, and this is perpendicular component. Now in this case normal stress is equal to force which is acting perpendicular to the surface by area of cross section. A. Now here, what is area of cross section in this case is x. Now we can write cos theta, this is A. From this expression we can write cos theta is equal to side by hypotenuse x. Okay, x is equal to A by cos theta. So here what is the cross section? Cross section is nothing but x. Now what is perpendicular component? Perpendicular component is f cos theta by x value is A by cos theta. This is f into cos square theta by A. So this is the expression for normal stress. Okay, so make a note of this. So in general, in the case of regular cross section, we can apply normal stress like this, which is perpendicular to the surface. So while calculating normal stress, we need to take a force which is acting perpendicular to the area of cross section or perpendicular to the surface. So in this case, if area of cross section is slant in position, then we need to take resolution of the force, and component of the force which is acting perpendicular to the area of cross section can be taken as f perpendicular while calculating normal stress. So normal stress will be A f cos theta by A cos theta. Then we can find f cos square theta by A. Now, if theta is equal to 1, theta is equal to 0 degree, cos 0 1, that means normal stress will becomes A. That means cos theta is equal to 0 means, so cos theta is equal to 0 means which is exactly perpendicular to the surface. Okay, that means normal stress will become 0 when theta is equal to 0 degree. That means along the normal we need to apply the force. Now shear stress is equal to tangential component or parallel to the surface by area of cross section x, which is equal to f sin theta by, what is the value of A? X is nothing but A by cos theta. That implies shear stress is equal to f sin theta cos theta. That means we can write f into sin theta cos theta by A. But by multiplying with A and dividing with 2, multiplying with 2 and dividing with 2, you get 2 sin theta cos theta is nothing but 2 sin 2 theta. So now sin 2A is called 2 sin A cos, that is f into sin 2 theta by 2A. Okay, so this is the expression for shear strain. Otherwise we can make this as f sin theta cos theta by 2A. Like that we can keep and we can represent like that. Now if theta is equal to 45 degree, so 2 into 45, 90, sin 91 f by 2A, this is shear stress. That means if theta is equal to 45 degree, then you will get shear stress will becomes maximum. Okay, so sometimes by changing this area of cross section is different, slant area of cross section, they may ask the question. So we need to take this situation into consideration. Okay, this is about stress and its different types. So there are two types of stress, normal stress and shear stress. So for isotropic solids, stress ratios will be like this. In the case of slant area of cross section, we can take normal stress and shear stress like this. Okay. So next topic, strain. Strain is nothing but change in dimensions by original dimensions. Change in dimension by original dimension. So this dimension means length, breadth, area of cross section, whatever it is. So change in dimensions, and this is also same dimension. So dimension both will cancel, then there is no units and dimension. So strain has no units and dimensions. Strain has no units and dimensions. Okay, right. Now types of strain. So here first one we have longitudinal strain. This is change in length by original length. So first one is longitudinal strain, change in length by original length. So strain has change in dimensions by original dimensions. Strain has no units and dimensions. So first one is longitudinal strain, which is change in length by original length. So it has no length meter, change in length meter. This is also meter, but cancel. There is no units and dimensions. Next, second one, volume strain. Volume strain or bulk strain. Volume strain or bulk strain. So this is equal to change in volume by original volume. Change in volume by original volume. And third one, shear strain. So this we need to understand somewhat clearly now. So what is a shear strain? Is nothing but shear stress by shear strain. So change in that means shear strain we can represent with theta, or which is equal to tan theta. Then how we need to find this shear strain? So for that purpose we will take an example. Now for example we will take a cube. This is cube. Now we are fixing this lower face of the cube. So this lower face of the cube is fixed. Cube is fixed. Now we are applying tangentially force on the upper layer or upper surface or upper face. So lower surface or lower face is fixed, and we are applying a tangential force or tangential stress or shear stress tangential to the surface. So this is three-dimensional representation. So the same three-dimensional representation we can see with the two-dimensional representation. So this we can take as lower fixed surface. So when we are applying force on this, then what happens? This is lower fixed surface and this is upper fixed surface. So both are exactly opposite to each other. But as we are applying force on the upper surface, so this upper surface will displace from this original position to some other position. That means the upper surface, because of this tangential stress, is displayed from its original position to some other place, like this. So now actually this end of the surface is exactly at this position, but because of this tangential or shear stress, it is displaced from this position to this position. Now this is called a relative separation between the two layers or two surfaces or two faces. whatever it is we can take. And what is this? This is length of the face or side of the surface. This one. Now we can take this is lower surface and this is upper surface. So how this upper surface is displaced with respect to lower surface, we can identify by taking an angle theta. Now tan theta is equal to delta L by L. What is delta L? Delta L is nothing but relative separation of upper surface with respect to lower surface. So relative separation of upper surface with respect to lower surface is represented by delta L divided by what is L? L is the perpendicular distance between the two surfaces. So this is what we call it as shear stress. Now shear stress tan theta, if the theta is very small angle, then tan theta is equal to theta when theta is very small. So for small angles sin theta is equal to theta and tan theta is equal to theta and cos theta is equal to 0. Cos theta is equal to 1. Now we can take tan theta is equal to theta. Now we can take tan theta is theta. So theta is equal to delta L by L. This is called shear strain. So shear strain theta is equal to delta L by L. So this is somewhat different as we seen these two, longitudinal strain and shear strain. So both the formula are looking like same. But here, what is a longitudinal strain? Change in length by original length. For example, you have taken a wire of length L is hanging from rigid support. This is original length. Now, because of applying some stress, as we are attaching some weight to the wire, now wire is extended up to here because of this weight. Now this is original length, this is extension. Now this is called change in length, that is delta L. So this change in length by original length is known as longitudinal strain. But this formula is looking like same, that is called delta L by L. What is delta L? Relative separation of upper layer with respect to lower surface. So in this case, L is the original length, but here perpendicular distance between the two layers or two surfaces or two faces in this case. This is called shear strain. So for the reason they may ask the questions on this shear strain. This is somewhat important. Again, we will take this expression while calculating rigidity modulus. Okay, so this is about strain and its types. Okay, so with this, the concept of three concepts what we assigned for today. The first one is interatomic and intermolecular forces. Second one is stress and its types, and third one is strain and its types. Okay, and then so what is meant by elasticity? So to explain this elasticity, we will take Hooke's law, and then breaking stress, breaking force, and then we need to discuss modulus of elasticity. Okay, the next class we will discuss the concepts of elasticity related topics. So today topics what we completed are interatomic and intermolecular forces, stress and its types, strain and its types. So in the case of stress, one of the important model is there. Now for example, so when we have taken a string, this is a string. So to this string A, stone is connected, or a stone is tied to this string. Now this is fixed at this point, and it is revolving in a circular path. Circular path. So in this case, when this stone is moving, the stone has to go in this direction. So without going, that means the stone is not going in this way, it is turning in a circular path and revolving in a circular path, which means because of tensional force, what is there in this string will provides the necessary centripetal force to revolve this stone in a circular path. So this tensional force is equal to centripetal force. So we know centripetal force is equal to mv square by r. Now this tensional force is due to elastic nature of this string, and also without breaking the string, the tension what is there in the string is providing necessary centripetal force to revolve this stone in a circular path. So this point is also related to elastic nature of this string. That is the reason. So here they will ask the question on this model. So T is equal to mv square by r. So based on this stress and strain, very simple numericals are there. You can practice those numericals. So with this, the concept of stress and strain, intratomic and intermolecular forces are. This is for today class. Then tomorrow we will meet to discuss elasticity, breaking stress, breaking force, and we will try to complete the Young's modulus also. Okay, thank you.